Hey everyone, continuing with our transformations, we have the reciprocal 1 over fx. Essentially, you'll be given the graph of y equals to fx, like the one you've seen down here, and you are tasked to sketch the graph of 1 over fx. So how do we do it? Now think of it logically, with the idea that if you had the point a comma b in y equals to fx, then of course you end up with a comma 1 over b in y equals to 1 over fx, because fx equals to b, then 1 over fx, well, is simply 1 over b. So that's the main idea. And of course, there are some key and actually very recognizable features where we look at when b is approaching infinity and b is approaching 0, or when b equals to 0. Alright, so we see what happens. And we have this example right here. Now you notice that, first of all, b can't be 0. Right? If b equals to 0, then you know what happens to 1 over 0. It's undefined. And what do we do with undefined? It becomes a vertical asymptote for our x. As such, we notice that we have an intersection in this graph here at 0, 0. In our fx, y equals to fx. That means in our 1 over y equals to 1 over fx, we will get 1 over 0, which is undefined. As such, we have a x asymptote at x equals to 0, a vertical asymptote at x equals to 0. Alright, which means that now we can split the graph into 3 parts, right? We have one down here, and this part down here, because we have a vertical asymptote that splits the 2 graphs already. Alright, so from here, let's sketch the one on the left first, the negative x region. And let's take a look what happens from here all the way to down here. Alright, now first thing first, this part is or was at infinity, or is approaching a very large value. It was a super big value. And what happens when we take the reciprocal of a very large value? Let's say this value is 99. Alright, it is very small, right? Approaching 0. As it gets larger and larger, it gets very close to 0. Alright. As such, we know that these values would be x equals to, y equals to 0. And as it gets closer and closer to 0, we know that the value is getting smaller and smaller. So 1 over 99 becomes 1 over 50, 1 over 50 becomes 1 over 2, and slowly it gets, you notice that the value increases from 99 to 50 to 2 to 0.1, because it's the denominator. As a result, you notice that these values start to approach infinity towards 0. Which means one thing. We know that these values start very close to 0, which means that there is a y asymptote at y equals to 0. And then approaches infinity, because it's now dividing by a very, very small number. As such, the first graph, part of the graph will look something like this. Alright, now you kind of notice a striking feature, right? It was decreasing, now it is increasing. And I think I've already shown you why. Right? Your denominator gets increasing, your value will be increasing at an increasing rate. Okay, you can use that with numbers. Now we look at the right side of our asymptote, x equals 0 asymptote, and we have this portion here. Same idea. Where are we at the start? We were very, very small, and it's negative, which means that our value will be in the negative region below the x-axis. As such, this would be in negative infinity for our 1 over fx, right? 1 over a very small value, it is a very big value. Because it's negative, it is the negative of a very big value, infinity. And then now, you notice that our value approaches a infinity at the x equals 0.5 asymptote. Now, we must think of it this way. How does the asymptote get derived? A vertical asymptote arises when there is 1 over 0. Alright, or essentially when the graph is undefined. So you can look at it this way. So now if the reciprocal is 1 over 0, right, and this gives back us 0. That means this becomes a y, or rather x-intercept at 0.50. Okay, and you notice that our graph will start from a negative region and will then intersect at this x-intercept right here. Okay, so from here, we have conquered the second part. Now it's time for us to look at the third part. Alright, which is this portion of the graph right here. We have a point, right, at 1, 2. And this is the minimum point. That means, again, by this idea here, if we have 1 comma 2, this then becomes 1 comma half, right? Because fx was 2, now we have 1 over fx, it is 1 over 2. And because it's a minimum point, this would then become a maximum point. Why is that so? You notice that the values before and after the minimum point are larger than the minimum point. That means fx for these values, these y values are larger. So if you take 1 over fx, the larger the value, the smaller the 1 over fx will be, right? The larger fx will result in a larger denominator. 1 divided by a larger number would give you a smaller number. As such, this then becomes a maximum point at 1 comma half. And you notice that at this part of the graph, it is jointed to this, all right? So what happens is you'll go up and then hit the maximum point at 1 comma half. Thereafter, what happens? Now look at what happens past the graph, all right, or towards positive infinity. Notice that in positive infinity, when x is approaching positive infinity, this approaches, well, positive infinity is getting larger and larger. 1 over a very large value then becomes 0. As such, as we hit the maximum point at 1 comma half, this then approaches y equals to 0. And that is our y equals to 1 over fx graph. Alright, so there we have it. A first example of how we actually draw our reciprocal graph. In the next video, I'll give you a complete summary of the different transformations.